In this video, we're going to finally look at definite integrals. So definite integrals I like to think of as the second large calculus concept, the first one being derivatives. Usually, a lot of times, limits are put into the pre-calculus curriculum, but that can be a large concept on the AP calculus test as well, so they're all important. But the AB form would usually go up through integrals, and then BC goes on to some more things that we'll see a little bit later. So, what is a definite integral? Well, a definite integral is just the signed area between a function and the x-axis. Now, there are lots of little things that can happen here. But first off, I want to say, in general, above the x-axis is going to mean positive integral, and below the x-axis is going to mean negative integral. And the notation is going to look like this. So this elongated S for sum, and we'll see that in a few videos why that's the case. These are the limits. And this is read as the definite. You don't really need to say the word definite, but you can. Integral from A to B of f of x. And I'm going to write all out with respect to x, but you can just say dx here. And this is how I'd read it off. A and B are the limits of integration. F of x, the function here, is the integrand. And this is basically the area between, so let me write this down, it's important. So the area between the x-axis and f of x from x equals a to x equals b. For now, I'm going to ensure that a is always less than b. If these are flipped, where I'm going from a large number to a smaller number, then it will change the sign, and we'll see that in a later video. So let's look at a couple examples, see how this works. I'm going to look at this completely graphically in this video. Later on, when we see something called the fundamental theorem of calculus, the second fundamental theorem, and I'll have a video on that up in a week or so, we'll see how to do this algebraically or analytically. So first example, evaluate the integral from -1 to 4 of 3 dx. Well, 3 is a horizontal line. My limits of integration are -1 and 4, so I'm going from -1 on the x value up to 4, and this forms a rectangle between my function and the x-axis. The rectangle is 5 units wide, 3 units tall. 5 times 3 is 15. It's above the x-axis, so the integral is 15. This one, I want to evaluate the integral from -5 to 3 of 1/3 x plus 3 dx. So this is a line that has y-intercept 3, slope 1/3, so up 1 over 3, up 1 over 3, or down 1 left 3, down 1 left 3. And so this function looks like this. I'm going from -5 up to 3. And this can be a little bit harder to see. So let me go from my x-axis to the curve and shade between the curve, or between the line in this case, and the x-axis. And in here, I have a few options. The easiest option, or the quickest, most direct option, is to see this as a trapezoid. Or I could even try to cut this off here and have a rectangle and a triangle. I'll do it as a trapezoid. Most people don't see this as a trapezoid very well because they're used to seeing the bases. They're used to seeing a trapezoid look like this. That's a terrible trapezoid, hold on. But this is still a trapezoid over here. The parallel bases are here and here. Now I can clearly see that the base here is 4, but this is a little bit harder. It looks more than 1, maybe not quite 1.5, but if I'm unsure, the way I can know how high this is going back to the integrand. So this happened at x equals -5, so 1/3 plus 3, evaluated at x equals -5, well that's, sorry, 1/3 x plus 3, that's -5/3 plus 3, which is 9/3, and that gives me 4/3. So this right here will be 4/3, or 1 1/3. These are the two bases. The height of the trapezoid is 1, 2, 3, 4, 5, 6, 7, 8. 3 minus -5. And so my area is going to be 1/2 base 1 plus base 2. So base 1 is 4/3. Base 2 is 4. Times the height. To make my life easier, I'm going to do half of 8 and get a 4 out here. 4, well, I'll do this in some steps just in case we're having trouble with fractions. 4 is 12/3. So I have 4 times 4 plus 12 is 16/3, which is 4 times 16, 64/3, and that is the value of my integral, 64/3. In these two problems, we kept things positive. But what happens if I go negative? So, line, y-intercept's 3, slope is -2, so I go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, or up 2 left 1, and I get this line. And as you can see, I'm being careful about graphing. If I graph these carefully enough, I can do a lot of this work simply knowing that it's a signed area. Here things are a little bit harder. I want to go from 1 to 4. Those are the limits of integration. From 1 to 4. And people have a heck of a time drawing this in. Where does it go? So I go from this to the curve, go from this to the curve, and I shade the space between my curve and the x-axis. Now what I see are two triangles. This triangle here, the base is 1/2. If you're unclear, I could set this equal to 0, get -2t plus 3 equals 0. Subtract 3, divide by -2, t equals 1.5, and you can see that this is 1.5. We started at 1, so that's 1/2 there. The height here is 1. That would make this 2.5, so 5/2. And this right here, I'm going to make this -5, but you can deal with it as a +5 and just wrap it up at the end. Now this takes a little bit extra work, so I have two triangles. The first triangle, so area 1, is going to be 1/2, base is 1/2, height is 1, which is going to be 1/4. This triangle here, I can either use the magnitudes of these, 5/2 and 5, or I can use this -5. I'm just going to do the magnitude, so I have 5/2 times 5. Half of 5/2 times 5 is 25/4. But This is below the x-axis, so the integral over here is going to be negative 25 over 4, and the integral here is going to be positive 1/4. And so to find the total signed area, I just add them up. 1/4 plus a negative 25 over 4, which is going to be negative 24 over 4, which is negative 6. Let me double check. Another way to see it is this can cancel out with that. And on this trapezoid, 1, 5, yeah, negative 6. Okay. Now this one confuses a lot of people. And notice I'm not always doing with respect to x. I'm sometimes putting in, last one was t, this one's beta. So let's evaluate the definite integral from negative 5 to 0 of the square root of 25 minus beta squared d beta. A lot of people have trouble remembering this the first time they see it. This is a half circle, the positive half circle with radius 5. So in general, the square root of r squared minus x squared is the positive half circle, the negative one is the negative half circle. So in here, I'm just going to sketch my circle. Now, I'll take my time to sketch it carefully, but once you notice that it's a half circle up there, it actually gets very easy. So because of the radius being 5, I actually sort of have these nice right triangles that fit in here, so I can get some really nice points and get something that's pretty darn close to a half circle. I know sometimes when you try to draw a half circle, it looks pretty terrible. I'm going from negative 5 up to 0. So while this has a graph that's a half circle, I'm only actually looking at half of that half circle, which means it's a quarter of the total circle. So the area is going to be a quarter of pi r squared. The radius is 5, which will be 25 pi over 4. I hope this helped out. Feel free to comment below if you have any questions.